In this presentation, we have to discuss about basic concepts of group theory. A group is a set of elements that are finite or infinite in number and should satisfy certain conditions. Here, G is a group which has the elements E, A, B, C, D and so on. Here, E is the identity element. Then the group should satisfy the given four conditions. The first condition is the composition of any elements A and B of group G should also be an element of the group. Say A and B are the elements of the group G. If you make the composition of A and B, the resultant element should also be present in the group G. This is the first condition. And the second condition is a group should have an identity element E such that E into A equal to A into E equal to A. Here E is identity element, A is one element. The product of identity element and the element A should be equal to the same element A. Third condition is for every element A there exists a unique element X such that A into X equal to X into A equal to identity element. The element X is called inverse of the element A and vice versa. Here if X equal to A inverse equal to A inverse A equal to the identity element E. Here A belongs to G and A inverse also belongs to G. And the fourth condition is the elements of group G should satisfy the associative law for any elements A, B, C. These elements are present in the group G. A composite B composite C equal to A composite B composite C. If this condition is satisfied, we can call this one as associative law. So a group should satisfy all the four conditions. Then order of a group. The number of elements in a group is called its order. A group containing a finite number of elements is called a finite group, and a group with an infinity number of elements is called an infinity group. Next topic is abelian group. Usually the elements in a group may be subjected to commutation or may not be. But abelian group is a special type. In this type, all the elements should subjected for commutation. The product of group elements is not necessarily commutative, that is AB not equal to BA. If the elements of a group are commuting, then the group is said to be abelian, that is AB equal to BA. The next type is cyclic group. A group generated by a single element is called a cyclic group. Consider X be an element of a group G, then all integral powers of X such as X square, X cube must also be in group G, and X power n should be equal to the identity element E. Then the group is said to be cyclic. Here the value of n gives the order of the group. Suppose a cyclic group of order 3 is taken for our consideration. G equal to A, B, C. Here three elements are present. Then the first element is A. The second element should be A square. That is the value of B equal to A square. And the third element C equal to A cube. Then the value of A cube should be equal to identity element E. Then we can rewrite this group as G equal to A square E. Then we can say this group is a cyclic group of order 3. All the cyclic groups are abelian in nature. but all the abelian groups are not cyclic.